Hi friends, in this video I am going to discuss about synchronous and induction machines. This is one of the subjects which is included in the 6th semester of Kalam Technological University, and I will be covering all the topics included in the syllabus of the same university. First of all, let me give you a brief idea of the topics that will be covered under module 1 of the subject, and these are the topics that will be covered under module 1. First of all, we will start with the principle of operation of three-phase alternators. After that, the constructional features will be discussed. The stator construction, rotor construction and type, all those things will be discussed. After that, the types of armature windings. There are different kinds of armature windings in a synchronous machine. It will be explained. Then comes the EMF equation. After that, some numerical problems based on the EMF equation will be done. Then comes the harmonics. After that, the rating of alternators, the parameters of armature winding such as armature resistance, reactance and all. Then comes armature reaction. After that, the equivalent circuit, phasor diagram. And finally, we will wind up with load characteristic and power flow equations. So in today's session, I will just give a brief introduction on alternators. So from the heading itself, it's clear that an alternator is an AC generator. It's a name given to an AC generator. So we all know the purpose of a generator. A generator converts mechanical energy to electrical energy. And an alternator is an AC generator. So that's the first point. An alternator is a machine that converts mechanical energy to electrical energy at a particular voltage and a fixed frequency. We all know that the frequency of the supply that we are getting is 50 Hz. That means the frequency is fixed. So in order to generate a voltage at a fixed frequency, as the frequency is always dependent on the speed with which the prime mover is rotated, in order to keep the frequency fixed, the speed with which the machine is rotating should also be fixed. That's the second point. To achieve a fixed frequency, the machine must be driven only at one speed called the synchronous speed. And the name of that particular speed is known as synchronous speed. It is due to this reason that these machines that are driven at synchronous speed are called as synchronous machines. So, just simply we can say that synchronous machines are the machines that are driven at synchronous speed. And the name synchronous speed is given to that particular speed with which the machine is rotated to generate a fixed frequency. In short, alternators are AC generators that run at synchronous speed. They are AC generators that run at synchronous speed. And we need to know some equation to find the synchronous speed, right? If we need to generate a voltage at a frequency of 50 Hz using an AC generator, we have to find the speed with which it should be rotated to generate that particular frequency voltage. So there is an equation for the synchronous speed, and the formula for synchronous speed is given by Ns is equal to 120 F by P. This is a formula to find the synchronous speed, and in this formula Ns represents the synchronous speed, 120 is a constant, F represents frequency and P represents the number of poles. Here it's given. So once again I will remind you the points. An alternator is a machine. It's an electrical machine that converts mechanical energy to electrical energy. That means it is a generator. and that particular electrical energy will be having a particular voltage and a fixed frequency. And in order to achieve the fixed frequency, as I have said earlier, the machine must be driven only at one speed called synchronous speed. The frequency is always dependent on the speed with which the machine is rotated. So to keep the frequency fixed, we must rotate the machine only at a fixed speed. Otherwise, if we vary the speed, then the frequency of the supply will also be varied. So for the frequency to be fixed, the machine should be driven at a particular speed, and that speed is termed as synchronous speed. The name given to that speed is synchronous speed. And since these machines are rotating at synchronous speed, another name for these machines are synchronous machines. So another name for this AC generator is synchronous machine or alternator. In short, alternators are AC generators that are run at synchronous speed. This is a simple definition for an alternator. And the equation to find the synchronous speed is 120 F by P, where F is a frequency, P the number of poles, and Ns is a synchronous speed. So this is just a basic idea of an alternator, and I will come with the rest of the topics one by one in the next few days. Thank you.